Hello, sir.
Sir. Good afternoon.
Good afternoon, sir.
Okay. Nice to see you.
Same here, sir.
Yes.
After a lot.
Yes. How is your family?
All good, sir. Everyone good.
Fine.
Yeah.
Okay. Now what you can do is you can share your screen. So by the time you will give a small introduction,
Sure.
then you can start.
Sure.
And participants are also joining.
Okay.
Yes.
Sir, what is the what are the participants? All are faculties?
I think 60-70% are faculties.
Okay.
And research scholars from IIT.
60-70%.
Yes.
Okay. I hope it is visible, sir.
Yes, it's visible. So I invite Mr. Charan to introduce Dr. Ankit Gupta. Charan, please.
Thank you. I would be very grateful to introduce the esteemed speaker. Dr. Ankit Gupta presently serves as an associate professor in the Department of Civil Engineering at the Indian Institute of Technology, Banaras Hindu University, Varanasi, India. He obtained doctoral degree in civil engineering, major transportation engineering from Indian Institute of Technology, Roorkee, and Master of Technology degree in earthquake engineering, major structural dynamics from Indian Institute of Technology, Roorkee. He holds a Bachelor of Engineering degree in civil engineering from Government Engineering College, Kota, under Rajasthan University. His experience is in payment maintenance and performance modeling, mechanistic analysis and design of payments, traffic flow, modeling, and safety. During the last 12 plus years, he has been involved in several academic, research, and professional activities. His major research studies were focused on fundamental payment design using mechanistic analysis, waste utilization in various payment layers, and traffic capacity and safety studies to enhance quality of ride life initiatives. He is also associated with various national and international societies such as American Society of Civil Engineering, International Society for Concrete Payments, UK-based World Conference on Transport Research Society, Eastern Asian Society for Transportation Studies, Indian Road Congress, Institute of Urban Transport, Indian Geotechnical Society, iSmart, etc. He serves as an editorial board panel member of the international journal ICE Transport. Advances in civil engineering, innovative infrastructure solutions, Springer, International Journal for Traffic and Transportation Engineering, Serbia, and reviewer of more than 30 peer-reviewed journals. He has authored, co-authored, and contributed over 150 papers in peer-reviewed journals and conferences, and over 20 reports, press articles, newsletters. Further, he has also given many presentations in several countries, including India, USA, Netherlands, Indonesia, Switzerland, Austria, Greece, China, etc. During the last several years, he has been guiding, mentoring several undergraduate, postgraduate, and PhD students, researchers, engineers, and practitioners. This is a very brief introduction of our esteemed speaker. Sir, I request you to carry on with the session. Thank you, sir.
Thank you. Thank you, everyone. Thank you, Institute.
Hello, sir. You can unmute.
Sir, I have unmuted. Am I audible? Am I audible?
Yes, sir. You are audible.
Yes, sir. You are audible.
Okay. Thank you. Okay, so thank you, everyone. Thank you, Ramaiah Institute of Technology, for giving me this opportunity. A very warm good afternoon to every one of you. Uh, this is a faculty development program on advances in highway technology and traffic systems. Obviously, we are more focusing over this word, advances. Uh, so I'll be covering few advances in the pavement evaluation part. But before going to the advances part, obviously a slight introduction or some part of the pavement evaluation is important. Okay, so obviously the time to cover this part is very limited. We have approximately an hour. Okay, so we'll try to move fast. So I will be taking some crude assumptions that you know few basic things about the pavement, some terminologies about the pavement engineering and the pavement design. Okay, so let us move without wasting much time. I don't mind if you will post me questions in between also. If anyone is having any difficulty or any questions are arising, I will be happy to answer in between also. So let us have to be having more interactive session rather than it's just a one way of giving the things. Okay. So coming to the pavement evaluation part, we will discuss few things, the types of the evaluation, majorly the functional evaluation and the structural evaluation. In the functional evaluation, we'll be discussing that how the things evolved, the ratings of the pavements, okay, with the various perceptions, with the various test procedures. Then how this roughness word has arrived, what is the meaning of a roughness, then the surface friction, then the surface or the visual defects, and then what are the indicators and what are the future about the functional evaluation. Similarly, we'll try to brief upon the structural evaluation part, the non-destructive techniques and the destructive techniques. Then some futuristic technologies which we are seeing, okay, the more advancements which we are looking at nowadays. And then what are the opportunities and challenges behind before us? Maybe some of us are the early stage researchers, or maybe the researchers, we all as a community, what are the opportunities and the challenges which lies ahead in this area. Okay. Before starting, I would like to acknowledge the various IRC codes and the manuals from where I have taken few datas and few snapshots also. I'd like to thank the Pavement Interactive website also for taking few again pictures and few material. The study material which I and my colleagues at IIT BHU Varanasi normally gives to the students, various internet sources for the images I have used, and to all of my teachers and the students. Now, this is a brief idea about the pavement life. We all probably must have seen some kind of a graph like this, that initially the pavement conditions are good. Over that time, you will see some kind of a distresses are there, some kind of the cracks and the other visual distresses are there. Over the time, then the cracks becomes more severe, the distresses becomes more severe, and then somewhere at some conditions, at some more age, it is like a totally a failed pavement. Okay, so this is how the pavement life is there. Okay, now our idea is to uh, extend this life as much as possible without having the least intervention in terms of the money. Okay, so this is what our objective is. And especially nowadays, this pavement evaluation and the maintenance part has taken a very steep progress in terms of uh, the idea or the in terms of uh, the the issues that are being created by the pavement evaluation is giving more importance nowadays since last 1 to 2 decades, because now the agencies or the governments have now start recognizing that whatever the pavements they are constructed, these are not only the pavements, these are the assets. Okay, so to manage these assets is equally important as compared to the construction of these assets. So now nowadays we talk more about like constructing a road like 40 kilometers per day, 45 kilometers per day. Okay, so we are aiming something like this. But at the same side, now we are also talking about the words something like asset monetization or the asset management or the maintenance of these assets. Okay, so hence to maintain these assets, we need to evaluate these assets continuously. Okay, so there is a question like why we should evaluate. Okay, so this is how the pavement new condition, if you are not evaluating, it will have in some of the years you will see a steep kind of a decrease in their serviceability conditions, and then sooner or later it will again go to the fail condition. Okay, now if I do the interventions, the maintenance interventions at the different stages, how can I extend my pavement life? I can see here, like maybe just at the starting age of the distress starting, if I'll do some kind of a minor interventions, you will see I have increased my pavement life. Okay, and then the kind of the failure I will get, it will be very less as compared to its normal usual life. Okay, so this red line represents the normal failure if I'll not do any intervention, and this is the green line will represent my deterioration over the time if I'll do some slight intervention. And probably you can see the difference in the pavement condition which I'm doing after the age of the 15 years. Similarly, if you are doing again the intervention for this, again a minor kind of the interventions is required, again you have increased the serviceability conditions, again it was decreasing down, again some minor rehabilitation, and then you are doing it. If you are not doing something, then maybe at the end of its design life you have to go for its major rehabilitation. And obviously when this length of this major rehabilitation, this length of a line increases, the kind of the investment which you have to incur or which you have to do on such kind of a major rehabilitation will also be very high. Okay, and then again this life decrease will start. Okay, so this is the kind of the various opportunities or the various interventions which is available for an engineer, but the whole challenge is at which point I have to start. Okay, and then what with the frequencies of again I have to do these interventions, and whether I have sufficient fund for those things or not. Okay, so it's a basically a management of the money, the management of the manpower, the management of the resources. Okay, so the big questions is when I should do these kind of interventions, whether I should do it from this point, at this point, at this point. Okay, and then what kind of interventions I have to do. So there are various maintenance techniques which probably we are not covering in this lecture, but what kind, because there are so many different type of the maintenance techniques are there. So what to do? Okay, so it is all about managing our assets, which are in the form of payments, and managing our funds. Okay. So this is a very brief general idea which we have discussed, that whatever the structure or the asset we are building, it will deteriorate over the time. Okay, irrespective of any load, irrespective of any climate factor. Okay, especially the pavement we are talking about, the performance is a function of its relative ability to serve the traffic over a period of a time, because that is the main purpose of the pavement. Until unless if it is serving the traffic well, there is no problem with the pavement. The only problem comes that when it is not able to serve its traffic. Okay, so it's a system of objective measurement is in the performance. Now the question is very deep, that whether we should go for a subjective measurement or an objective measurement. Subjective measurement is based on the perceptions. Objective measurement is something which we have the quantifiable values. Okay, so the periods or the frequency of the evaluation is very much required to find out its structural condition and the remaining life which a pavement is having. Okay, so how much more the pavement can serve satisfactorily before the failure. If I'll find out this design or the remaining life, the residual life, I can manage my assets in a better way. Okay, but for that I need to do certain evaluation. For that I need so many tools. Collection of a data, again some kind of the equipments are required for this data collection. The analysis tools, how you are doing the analysis, at the various levels you have to do the intervention. So what will be the economic considerations of those interventions? Okay, so that is the part of the analysis. And then finally, out of the various alternatives you will have, what is you are choosing? So making the right choice and the decision to increase the existing life by a certain amount of year in a limited funds. Okay, so limited funds is again a very important consideration. We do the various kind of the evaluations. Okay, we find out the maintenance priorities, then we determine the strategies, and then finally again after doing the rehabilitation we again do the pavement performance. Okay, so this is all a vicious circle we need to do for our pavement. Coming to the types of the evaluation, most of you are very well known about this area. Okay, but the two major type of the evaluation which we are considering in our country is the functional and the structural evaluation. Okay, and we have our performance models for the structural evaluation, functional evaluations. Okay, some of the countries consider this safety evaluation in terms of the functional performance. Okay, and some of the countries consider is as a different evaluation. So they have the structural performance, they have the functional performance, and even they are having the safety performance also. Okay, so this is again depending upon country to country, but right now we are considering the safety as a part of our functional performance. We will come into detail about the functional and the structural performance. Okay, so this is what we can understood by now, that rate of deterioration of my pavement is a function of the initial condition. Okay, so if my quality control and the quality assurance is not good, my new pavement is not well. Okay, so maybe the initial condition is not good. So there will be more or a severe rate of the deterioration. The traffic loading, higher the traffic loading, more is the overloading, probably more will be the rate of deterioration. The more harsh climatic condition, probably rate of deterioration will be more higher. Material properties, if it is not satisfying the required limits, again the rate of deterioration will be higher. And similarly, there are various other parameters surrounding land conditions. Okay, the kind of the materials or the kind of the chemical morphology of the materials available. Okay, so there are so many issues which is affecting the rate of deterioration of the pavement. But now to evaluate my pavement, I need to do some kind of a performance evaluation. Okay, I can classify the performance evaluation into two types right now: functional and the structural performance evaluation. Okay, so functional evaluation, very simply we can understand that whatever the things which is affecting a user is coming under the functional evaluation. Okay, like for example, if some cracks are there, but if it is not affecting my riding quality, then probably cracking will not come under the functional evaluation. Okay, so any failure, structural failure, if it is there, but if it is not affecting my functional performance, it is not coming under the functional evaluation. Okay, so it is totally based on the user's perspective. Okay, if a user is feeling good on a deteriorated pavement also, it means there is no problem with the functional evaluation. That there is no problem with the functional performance. Okay, so what do users expect or what they want is basically we consider in the functional evaluation. Okay, so as a user, we always expect a comfortable, safe, and the economic ride on our pavement surface. Okay, so strength is not considered as a factor by the user, and most of the user does not know that what are the strength of the pavement. Okay, only we pavement engineers know that there is some resilient modulus values of each layers, there is some CBR value of some my base sub base layers. Okay, but most of the user does not know anything about this thing. For them it is a very good, okay, I haven't experienced any kind of a bumps, so it was a very comfortable ride for me. Okay, so strength is probably not considered as a factor in the functional evaluation. Now it can be evaluated in various ways. The history started like just by the visual condition. Then there were some indexes has been developed because there are so many different distresses are there. Okay, from those different distresses, we have to come to a single parameter. So the people have started using some kind of indices, starting with the Asho road test way back in 1962. They started. Then they come to the roughness one because it is directly affecting the user. And then onto the safety side, the skid resistance measurement. Okay, so these are some functional evaluations which we have to do. When I talk about the first one, the distress evaluation, mostly it consists of my visual pavement condition survey. Okay. Now this visual pavement is something easy also and sometimes tough also. For a small section, it is very easy to do this visual pavement condition survey. But for sections like kilometers long, like hundreds of kilometers, thousands of the kilometers, it becomes very difficult to do this visual evaluation. Okay. But what we evaluate in the visual is the type of the distresses, the extent and the severity. Extent means like how long it is there in the section. And the severity is that how much severe it is there. If you talk about the cracks, how much the width of the cracks are there. If you talk about the potholes, the area of the potholes, the depth of the potholes, all this represents the severity of the visible distresses, such as so that the corrective action can be taken on the visible distresses. Depending upon the type of the distresses, occurrences are recorded in terms of the percentage area, linear meter per centimeter, or per cubic, or per square kilometer, or per 100 meter, per square 100 meter, something like this. Okay, so there are different type of the recordings the people have done. Okay, like for example, they have done with the threads, with the cracks. So with the cracks, they have identified the length of the cracks with the help of the thread. Okay, then they identified the width of the cracks. Okay, maybe within the range of less than 1 mm, 1 to 3 mm, more than 3 mm, etc. Then they started identifying the area of the distresses as compared to the area which they are examining. So for example, we are doing a survey of like a 100-meter section, and in that 100-meter section, whatever the distresses are being visible, we'll try to find out an approximate area of that visible distresses, and we can write that this amount of the distresses is visible in the 100-meter length of a section. Now, when I say 100-meter length of a section, the width of the section, I know either it's a single lane, maybe 3.75 or 3.5 meters, or maybe it's a 2-lane, 4-lane, etc. So width can easily be find out, and then I can find out the area. Okay. Now, for the network level, means for a big or on a broad scale evaluation, these statics are typically captured for each 100-meter section and further summarized to the 1-kilometer section. Obviously, this is not a very hard and fast rule. Depending upon how big is your network, you can do these kind of evaluations, maybe for a per kilometer section, or maybe for one section in 5 kilometers or 10 kilometers, depending upon the budget you are having. Okay, and depending upon your experience and depending upon how in-depth analysis you want to do. Okay, so it is totally a freedom kind of a thing, which has to be utilized or which has to be used by the engineer in charge very very wisely. Okay, that what is the frequency of the evaluation they are doing. Okay, but for a small level evaluation, for a small level kind of a project, you can do these things maybe in terms of the visual things, maybe just by walking on the road, you can evaluate all these things and you can note down these things. Okay, so obviously when you are doing the things verbally or visually and by walking, you can visualize many distresses in more detail. But when you have to do the lengths of kilometer, sometimes the extent of the details are missing in those evaluations. Okay, these are some of the distresses which is observed in the flexible pavement. Right now I'm not going into the detail, but I'll just taking the names. So in case if you are already acquainted of these distresses, it is all good. If not, you can easily search on the Google or the images. Sometimes these are very easily you can see on the Google images. Okay, like rutting, patching, localized failures, block cracking, alligator or the fatigue cracking, the longitudinal cracking, the transverse cracking, raveling, flushing, bleeding. Some with the rigid pavements are the spelling, the punch outs, sometimes the patches of the binders, the concrete patches or the cement patches. Then the temperature crackings are the corner breaks, shattered slabs with the longitudinals, and the transverse cracks are there. Then the joint spacing are being opening up. Okay, all these are the different kind of the failures. Now coming to the evaluation part, that how the history has started. Okay, so there were initially like 1962, the people have started the first road test was designed, that is by the ASHO road test was there, and the outcome of that was the PSI, the pavement serviceability index, which they have developed. So it was basically based on two different things. One is the roughness and one is the distress condition of the pavement. Okay. Now, after that, the people have developed few more things like a roughness index based kind of a indices also. But that is totally based on the roughness. So there was no any incorporation of the distresses in those indices. Okay. So there are different type of the distresses, maybe from 0 to 5 were there, 0 to 1 considered as very poor. This could be filled out maybe by a people or a group of people. Okay. And then you can come out to the average value. Okay. The pavement classes again can be classified into different types. Again, these are some just examples. Because different DOTs in the US, they are having some different classification formats. So they classify the format the pavements in a different PSI values. Okay. Now, depending upon these PSI values, you can easily find out these things, that what is your preventive maintenance, at what stage you have to take. Okay, because these are already being guided in the particular DOTs or in the particular guidelines which has been followed in the different states. Okay, so maybe like if for some high class roads or some the hierarchy in the roads like expressways and the freeways, maybe like you can consider that 3 is a the terminal condition. So from the 3, you have to start doing some kind of a rehabilitation for your pavements. But maybe for a low volume roads, you can do up to like 2 also. Okay, so maybe the 2 is the terminal condition, and from 2 you can start doing your major rehabilitation works. Okay, these are few different definitions and of the various ratings which has been developed over the time. Present serviceability, individual present serviceability rating. This is something about and the present serviceability rating is, all these ratings are basically being done by the individuals. Okay, on the basis of his or her perception. Okay, initially it was started like with a group of 5 people. Okay, out of those 5 people, one should definitely be an engineer in charge of that particular road. One person will always be an expert in the area of the pavement engineering or in the area of the pavement maintenance. One person will be at least the user of that road. He does not know anything about the engineering, but he is a regular user of that road. Okay, so these are the 3 minimum persons which should be there. It could be a 2 user with the 2 engineers and 1 expert, or 2 expert with 1 engineer and the 2 users. Okay, but these are the 3 different categories of the people: 1 user, 1 engineer in charge, and 1 an expert. Okay, the pavement expert. So these 3 should always be there to come to a general and an average value of the rating, which can be identified in between 0 to 5. Okay, now the PSI is a mathematical combination of certain parameters like slope variance and some cracking and the patching distresses. We'll discuss these things. And the performance index is the summary of the PSI over a period of a time. Slightly, I have not discussed these things in the more detail because presently our focus is more on the evaluation part. Okay, so now coming to the objective, the first objective measurement which was started by which was given by after the ASHO road test, in which they have used this particular equation, in which they have used the slope variance, they have used the rut depth, they have used the cracking and the patching values. Okay, so this is the first equation which has been given by the ASHO road test for finding out the pavement serviceability index value on the basis of the slope variance, rut depth, and the cracking and the patching. And the another similar equation was being designed for the rigid pavements. Okay, in which the slope variance is there. Rutting is almost considered nil in the rigid pavements. Hence, rut depth is not being considered in this equation, and the cracking and the patching is still being considered. Okay, so this is how the things have been evolved in the ASHO road test, and that has been considered. Okay, so obviously this is a starting point of the evaluation techniques. So again, I'm less focusing on this part because our idea is to discuss the present evaluation techniques and the what are the futuristic evaluation techniques. So kindly bear if I'm going fast from this point, because this is like I'm not thinking to go into the much detail of because of the limited time. Okay. Similarly, roughness can be easily measured with the help of a straight edge. Okay, and in between we can just find this depth with the help of a vernier caliper to be more accurate. Okay, and this measurement has to be taken after every 6.1 meter interval. Okay, cracking and the patching both are combined as a single variable. Okay, and then they can be expressed in terms of as a linear fit and the patching as a area, both per 1,000 feet square of the pavement area. So these equations are basically using the FPS units, okay, because that was more prevalent in the USA. Okay. Still, many of the countries are still are relying on the PSI equations for deciding their maintenance alternatives. Okay, but there are few deficiencies in these PSI equation, because you know that these equation, as I'm again and again discussing, it has been developed in 1962. Okay, so now the perception of the people might have changed regarding the serviceability in the last 4 to 5 decades. Okay, because the kind of the serviceability which we were expecting like 4 to 5 decades before was okay. Okay, like at least the pavement is there, we are good. Now our expectations are very high with the pavement, so maybe these equations may not giving you a correct serviceability index. Okay, it includes both the rideability and the surface defects also. So the cracking and the patchings are something like your surface defect, and your slope variance is talking about your rideability. Okay, so hence it's better to have separate measures. Okay, because slope variance more talking about the roughness part, the cracking patching more talks about the visual distresses part. So it is always good to have the two different indices for these two different entities. Okay, again, for finding out this roughness for the slope variance, we need to use the profilometer. Okay, because there was a 0.9 inches gap between these two wheels to find out the slope variance. So that is nowadays we are not using profilometers. Okay, so again, these are some of the deficiencies that we are not able to use these PSI equations now. And again, there is a lack of correlation between the distress parameters and the roughness. Okay, so both, like as discussed in this part, also the second point, the rideability and the surface defects does not have a good correlation. Okay, so still many agencies rely only on the roughness to estimate the PSI. So still there are few agencies which totally rely on the old PSI. Still there are few agencies, they totally rely on the roughness based PSI. So what they have done, that they have evaluated some roughness based indices, and then they have correlated those indices with the PSI. So you can find out the PSI and then you can correlate this with to the roughness only. Okay, so this is how they have done. What are more prominent, more prevalent, and what happened after this test was that the roughness was being more explored by the people. Okay, especially in a big experiment done in the Brazil. Okay, there they come up with a new parameter known as the International Roughness Index. Okay, so it is considered to be a more good and a more better parameter for measuring the road users' response to the comfort and the convenience. Okay, and then there are many equipments which can be used to find out the roughness in terms of the IRI. Okay, the fifth wheel bump integrator we have used in the country since long, still we are using it. Okay, Merlin is a low cost equipment, although it's a manual equipment, we have to do the manually, we have to use this equipment manually, but it is very cheap. Okay, very cost effective, and sometimes this Merlin equipment can be used to uh, um, for for checking the accuracy of our fifth wheel bump integrator also. Okay, and then nowadays we are using much more automated equipments, okay, which are based on the laser. Now coming to starting about the IRI part. So the roughness was, again, the people have started working on the roughness, and they could realize that there are two different methods of finding out the roughness. One is the direct method and one is the indirect method. Okay, so the indirect methods are which is obtained from the response type road roughness meters. Okay, so there are some RTRRM kind of equipments like your fifth wheel bump integrator. So it is giving the responses of the pavement and it is measuring those responses. Okay, so this is just an indirect measurements. Okay, there are few direct measurements also which we will discuss later. Okay, now this fifth wheel bump integrator, more details has been given in the IRCSP 16. The new version is 2019. Okay, so these are something about the details about the fifth wheel bump integrator, that it has to be used at a constant speed of 32 kilometers per hour. So we can, it's a good speed by which we can cover our long distances. Okay, the minimum, the standard tire pressure has to be maintained at 2.1 kg per centimeter square. It is whatever the vertical shocks are being there, that has been recorded in this fifth wheel bump integrator. Okay, and then the distance traveled is measured by the counting revolutions of the wheel. So there is a counter which find out the total revolution of the wheel, and we can find out the total distance traveled. Okay, then whatever the distances, whatever the values which is accumulated in terms of these vertical strokes, okay, by the help of those values we can find out the IRI. Although it is not giving directly the IRI, it is giving the value as BI. Okay, from that BI value, we have the correlations by which we can express those BI into the roughness values in terms of mm per kilometer. Okay. Frequent calibration is required. We can do with the help of the Merlin. So this is a low cost, but it's a slow equipment. Okay, so we can walk down, we can walk through this equipment. We have to take, this has been designed by the Transport Research Laboratory in the UK. Okay, TRL. The person who invented was Kundil, M.A. Kundil. Okay, so we need to note down these 200 values on a graph paper, which has been there on the on our sheet, which is there on our Merlin. Okay, after every revolution, you need to note down these points. Okay, and then you have to come to the value of D. Okay, the value of D means these are the characteristics distance in which 90% of these roughness values, these 90% of these roughness indicators are within this distance. And now within this characteristics distance, you can find out the various values of the IRI for the different kind of the road surfaces as given in the manual. Okay. So this is how the old things were there. Nowadays, we are using much more an advanced equipment, something like laser profilometers, okay, which is having a laser beams, which is there in the equipment ahead. Whenever it is moving, it is just giving the laser beams and it is measuring the profile, or it is basically noting down the profile of the surface. Okay, and that profile surface is being directly given in terms of the value and directly being given in terms of the images to us. The good thing about this equipment is that it can do the survey as fast as 30 to 100 kilometers per hour. Okay, you can install this laser profilometer normally in front. Sometimes in some of the vehicles they are installing at the back also. Okay. The IRI is an interesting concept, but I think we have already covered half an hour, so it is not wise to cover the idea about the IRI. Okay, so I'm skipping this IRI part for the right now. Okay, it's a very interesting concept on a quarter car model. Okay, that how these suspension and the damping mechanism is correlated with the IRI. So it is a kind of an indirect measurements which we have to use. Okay, so these are the standards for the quarter car models, the golden quarter car model. The stiffness should be the standard 163.3. The stiffness of the tire spring should be 653. The damper rate, axle mass, speed of the vehicle. Now, the good thing about this is that we have given all our roughness index values in the IRI basis. And with the IRI basis, we have the kind of the surfacing also we can decide, like depending upon the IRI. So if we are doing some bituminous surfacing, BC, SMA, SDBC, the minimum IRI we should get is something in these orders. Okay, and then we can find out that these are the good IRI surfaces, fair IRI surfaces, or the poor IRI surfaces. Okay, all these things are being given in the IRC 82, the code for the evaluation of, for the maintenance and the evaluation for the flexible pavements. Okay, so now this is a recommendation for selection of the appropriate roughness equipments. So now even our code also gives like what kind of the equipments you can use in the different kind of the terrain also, and the different kind of the speed also. Okay, so a terrain like plain, rolling, hilly, in the speed ranges of 10 to 40 kilometers, you can use various like the fifth wheel bump integrator, you can use automated road unevenness recorder, you can even use the car axle mounted bump integrator, etc. Okay, for the high speed facilities, normally now we have to use the laser profilometer or the ultrasonic sensor based profilometer. So most of our highways which are coming now is having on in the contract the laser based profilometers. Okay, so that is we need to. Even the guidelines for the measurement is also being given, like how in we have to do a single run in one direction or in both the directions, like up and down. Okay, all these things have been given in our code. Similarly, the guidelines for the roughness data reporting. Okay, so either you should give in terms of the roughness index or the international roughness index values. So IRI is normally a more prominent uh, uh, parameter which we normally use. Okay, for how many sites you need to calibrate is again all these conditions have been given in our IRC 82. Surface friction is again a second type of the functional evaluation thing. Okay, we are more concerned about the safety of our vehicle. Okay, so adequate surface friction should be there on the pavement so that we cannot lose the control of the vehicle in the unexpected situations, especially when the pavement is wet or slippery. Okay, there are few factors like bleeding, polishing of the aggregate, smooth macro texture, or the hydroplaning, or the inadequate cross slope, which is being considered. Okay. Now, to find out the skidding, we are basically finding out the skid number. Okay. Now, this skid number is directly correlated with the coefficient of the friction. Okay. Now, this coefficient of the friction is again a kind of a dynamic value which is being there when the tire and the pavement interacts. Okay, now this can be again evaluated by various ways. Okay, this is a mu meter kind of equipment in which you can do it in a dry thing also, or even you can do in the wet thing also. So you do not need to have an wait for the rainy season. Okay, it can directly spray the water, and in that spraying of the water it can find out the skid number or the coefficient of the friction. This is most widely used. Okay, very cheap, mostly available in the labs also. The British pendulum tester. So this British pendulum tester is again can be related to the skid number. It is giving you the BPN value. Okay, and that BPN value can again be correlated with the structural number. Okay. Oh, sorry, the skid number. Now coming to the surface defects, the best one is always the visual one, because once you visualize the distresses, you as a human being, you can use your brains for many things. Okay, for finding out the reasonings also. But nowadays you cannot do the visual distress survey for the again length of kilometers. So you need to have some kind of a image sensing technologies. Okay, so nowadays a combined vehicle which is having the laser profilometer, which is having all these cameras, everything is there, which can give you all these automated data. Okay, so these surface defects they can find out in the surface defects, cracks, deformations, disintegrations. All these can be done with the help of the imaging techniques. Okay, although there are some image based programs uh, which is coordinating these machines. Okay, and you need to be very sure about the accuracy of these programs. Okay, because sometimes the accuracy of these programs are not very good. Okay, so you need to again cross check these things with a small stretches where you have already done the visual survey. Okay, so you cannot directly and blindly should follow the results coming out of the equipments. Okay, this is just from the IRC 82. I've just taken that what are the permissible level of the distresses which is available, and how we designate these levels into the poor, fair, and to the good conditions for the highways, for the urban roads, for the MDRs and the rural roads. This is the distress based distress measurement performer given in the IRC. Okay, This is again in terms of the area if you want to find out. Okay, and these are some utility or the weighted values by which, because there are so many different type of the distresses. At a section you can get a high cracking but less patching. Okay, but you have to come to a one value of either a good, fair, or a poor. Okay, so by the weighted values you can arrive at these values, like it's a good or it's a fair condition, it's a poor condition. These are some indicators of the evaluation, some of the futuristic thing about our pavement evaluations. Okay, most of the things probably you must have heard at least, that nowadays we are using a lot of unmanned aerial vehicles. Okay, there's a lot of research going on in this area of using the UAV or the drones for evaluation or the functional evaluation of our pavements. The benefit being the large area can be covered with a small time. The another benefit is it is not affecting our traffic. Okay, so there's nothing like a vehicle which is moving, so it will not disrupt any kind of a traffic. Okay, the data, if it is, we have the software, it could be analyzed very fast. Okay, so whatever the data you are having, then you can analyze it early and then you can come to the maintenance alternative. But believe me, these all are giving you some kind of a objective evaluation of your pavements. The decision still has to be taken by the engineer. The maintenance decision still has to be taken by the engineer. Okay. Then there can be some application of the intelligent system. So AI, you can use the artificial intelligence programs also, that if they are finding out some distresses, some kind of the cracks here, then using their artificial intelligence, they even sometimes can find out the cracks. So like if they can find out the alligator type of the cracking is there, which is already been feeded into the AI systems, it can give you that probably the fatigue failure is there. Okay, so you can use so many AI and the ML techniques as a supplement to these data which is coming through the UAV or the drones. Okay, so these are just techniques. These are some futuristic techniques which can be used, but still I feel in the pavement maintenance or the pavement management systems, the role of the engineer is still the paramount or very important. Okay, because ultimately the decision has to be taken by an engineer. Okay, even you can come with a program of with taking the decision also, but believe me, that shall not be a wise one. Okay, because the issue with the pavement maintenance is that we have a lot of pavements which require the maintenance, and we do not have that kind of a fund. So we have to prioritize our funds on the basis of a certain thing. Okay, this is something about Bangalore. I was reading something. Okay, so then there was a thing that even for the low volume roads now they are scanning it with the help of the UAV, the unmanned aerial vehicles. Okay, so this kind of technology is hitting to the ground very fast. Okay, we need to be very vigilant, but yeah, we should be very clear that what are the advantages of these techniques and what are the disadvantages, or where should be careful from by using these techniques. Coming to the another part, the structural evaluation part. Okay, we are more focused about the structural condition of the pavement. Maybe my surface is very good, the users are very happy with the road, but I need to evaluate the structural condition because maybe there is some failure which has initiated from the bottom of my layer. Okay, so therefore I am very much concerned about the structural evaluation. Okay, it is majorly required for finding out the remaining life of my pavement. And if the remaining life is less, then I can go with the overlay thickness. The two major types are destructive and the non-destructive. In the destructive, we have to cut the pavements. Okay, by making a big holes or by taking the cores. Okay, the collecting the samples, etc. Okay, in the laboratories. And in the non-destructive testings, we have to apply to a certain loading, and then we need to get the responses for those loads, or we have to use some different kind of the waves which is traveling inside our pavement layers. And the movement of those waves can tell us about the material properties of those particular layers. Okay, and then we can do some kind of a back calculation. Okay, how this structural evaluation is started is again the same kind of the test which was done by the WASHO, the Western Association of the State Highways and then the CGRA was the Canadian Goods Roads Association. So these were the two agencies who started long back the structural evaluation. Okay, their whole idea was to find out the deflection. Okay, so they just want to find out this deflection value, and they have correlated the structural performance of a pavement on the basis of the maximum deflection value. Okay, the structural evaluation, there were some shortcomings because there were different kind of the pavements even getting the same amount of the deflection value, but the kind of the pavement responses which is there is could be difficult. It could be different. Like if we'll see the pavement response for this one, every this long distance is facing some kind of a deflection, and obviously you are getting the maximum deflection here. The another kind of the pavement, again the maximum deflection is same, but the responses is only limited to a certain distance. Okay, so a single deflection measurement sometimes is not giving you a very accurate value, and this we have realized, and then we have now started from the Benkelman beam deflection to a falling weight deflectometer method. Okay, so the structural response is measured under the static and the creep load conditions initially, which is only representing a slow moving vehicle. It is not representing a fast moving vehicle. And then we are interpreting this maximum deflection value to the modulus and to the remaining life, which is probably not a very accurate method. Okay, so then we started with the falling weight deflectometer, which is giving you the full load bowl. Okay, the response bowl which is been getting by the various type of the geophones which is attached in this falling weight deflectometer, and you can get a full deflection bowl, and then probably a more accurate values of the surface properties or the modulus values can be find out. Okay, this is a more simpler one, the dynamic cone penetrometer, again a low cost equipment, portable device. Again, it could be correlated with the CBR values, but it should be only used for the unbound layers. Okay, it is not wise to use this value, this equipment for the bound layers like bituminous layers. So it is always good to use this equipment, dynamic cone penetrometer, for the unbound layers. Okay, like your base, sub-base, or even for the subgrade. It can give you various informations like layer information, the modulus values, and even the structural number of the layers beneath. Okay, structural number is just a kind of a number which is representing the strength value. Okay, then in the future, or still we are seeing in few of the areas, the air coupled ground penetrating radar, or the simply word the GPR is being used. Okay, so it's a van mounted system which is providing a continuous profile of our layer thickness and the dielectric variations, basically the variations in terms of the modulus or the strength values, to a maximum depth of about 60 centimeter or 600 mm beneath the pavement surface. So by that layer, we are easy to find out the strength properties of our bituminous layers and the base and the sub-base layers. Okay, the dielectric properties are correlated to the material density and the moisture content. So the subsurface problems in the existing hot mix asphalt and excessive moisture in the base layers can be easily detected. Okay, GPR can also be used to identify the segregation of the materials beneath the layers, okay, and the low density of the materials in the existing HMAs. Again, for the PCC pavements is not, or basically the cement concrete pavements is not much useful for the GPR, okay, because of the similar kind of the material which is being there. Okay, even nowadays they are using this GPR on the drones also. Okay, so that is again a kind of a future research. Still people are finding out the appropriate height up to the drones should fly, and to note down these values. Okay, then there are some ground coupled. The only difference between these GPRs and the ground coupled one is that it is in the air. Okay, so it is not having a direct contact with the surface. Now this is a ground coupled, it is having a more surface contact. Okay, so this is the only difference. I'll not go into the much detail about the working methodology of the GPR. Then coming to the seismic based tools. Okay, again the fundamentals is again same, that we are basically imparting a wave Okay, then this wave is traveling in our pavement surface, and on the opposite side, we are just again encountering those waves. Okay, now the time period in which our wave is traveling, it is giving you as an indication about the material properties. Okay, so it is a portable seismic pavement analyzer. Okay, there are some different types like dirt, SPA, V meter, free resonant column. Okay, so there are different types are available. Depending, there are some changes in their technologies. Okay, even I am not very much aware because I have not worked in this area. Okay, so this portable seismic pavement analyzers are devices which are used in the field to measure the in situ properties of the pavement layers. They are just generating the seismic waveforms in the materials which is being tested. The elastic modulus at the small strain is proportional to the velocity of the wave propagation. So this is just working on this particular principle, that a small strain is proportional to the velocity of the waves. Okay. Then this is something more advanced, a total pavement acceptance device. Okay, a very costly one. Majorly, they are more using it for the airport pavements. Okay, some busiest airports they are using this thing, or even for the some good expressways they are using. Still in the India, I have not seen anyone talking about or anyone having this kind of a device, the total pavement acceptance device. So it has the capability of everything. Okay, so it talks about the rolling dynamic deflectometer. So it is rolling also. It is a with the help. It is taking the deflection values also. It is doing the GPR values also. Okay, so it's a air coupled GPR with a deflectometer. So both the things are there. Okay. Additionally, it is giving you the high definition video of the surface, the linear offsets in terms of the two wheel surfaces, high precision differential GPS coordinates, and surface temperature logging up to the pavement sections are conducted simultaneously. Okay, so there are so many things which is being done with the help of this total pavement acceptance device. The last one, we can always do these things with the destructive evaluation. That is a more conventional one. Okay, we can cut down some excavated area, or we can take down some core, and then we can find out the properties in the lab. So that is a destructive evaluation of the pavement structural properties. The first one is the trenching. Okay, so it's a big area which you need to trench down. A trenching has been developed to run the tests and the collect samples while minimizing the disturbance to the base material. So we are not disturbing much about the base, but only to the surface layers. The only thing is the trench size are more. Okay, it's in the range of like 1 meter by 4 meter, and each saw cut is deep enough to penetrate all the way through the HML. So all the HML layers has been cut down. Otherwise, this is the most excuse me, most widely used type of the destructive evaluation the whole world is using. It's a coring. Okay, so we take a core samples with the 10 centimeter bit and the 15 centimeter bit. Okay, core bits are there either of the 100 mm or something like 150 mm. So we can take the core samples and then we can evaluate those core samples in our laboratory. Okay, this is the augering part in which you are not taking the core, you are drilling the surface and taking the material out. Okay, so here you are not getting the core, but you are just getting the material from out. Okay, so it is mostly used for acquiring the materials to determine the depth and the quantity of the stabilizers for the full depth reclamation projects. Okay, so like up to what depth they have used the stabilizers. Okay, at up to what depth the stabilized layers are there. So it's a quality control kind of a thing, or maybe you can use this thing at a later stage for the evaluation also. Okay. Yeah, I was a bit fast so that I want to have some time for the interaction. Finally, the opportunities part is still the condition rating is a gray area. Okay, it needs a lot of data, and whatever the old things are there, the old PSI values are there, PSI equations. Unfortunately, we do not have any such equations for our Indian roads. Okay, so this is always a very good area for us to do the research. But I know I understand the bigger challenge of the data. Okay, so it's a considerable effort is to be done from the whole of community. Then we can come to certain better models. More research efforts are required to work on the low cost equipment. Okay, something which many agencies are facing the challenges now. Okay, because now the things are coming into the contracting mechanism. Okay, the more the sophisticated instrument, the more the skilled workforce is required. Okay, so if we can come up with some low cost equipments, okay, the technology is quite helpful, quite friendly to us. The only thing we need to devise those equipments in such a way so that the cost is less. Okay, those who are working in the data analytics area, okay, again, there's a wide domain is open for them. How to use this AIML? Okay, AIML is a very fancy word, okay, but how to exactly use this AIML? Can this be a more intelligent AIML? Okay, so that it can help us to make the decisions also. It is again having a wide scope, okay, and it can really bring a revolutionary changes, especially in the accuracy and the reliability of its results. But it is very important to keep on checking the results. Okay, you should not be blindly following these equipments results. Sometimes a cross check is always good. Database management shall be the integral part of the road agencies, so that whatever the data they are collecting, it should be available to the agencies for the research, or to whosoever who want to do a research on this thing. Challenges are the high cost of the equipments. Most of the equipments now you have seen, especially for the structural evaluation, are very high cost. Okay, survey takes a long time. Okay, so if you can do the things fast, that's why the drone and the UAVs are nowadays more fancy one, because they can do the things very fast. Okay, confidence in the value of the ratings. Okay, so this is something very interesting and challenging also. If my evaluation say that my rating is 3.5, how you will gain a confidence that it is really 3.5 out of 5? Okay, so this is something which is really interesting thing. How we can we include the user perception also in our ratings? Okay, correct selection of the maintenance techniques after the evaluation. It is a totally engineering business. Okay, so here there is no excuse. A pavement engineer has to be intelligent enough, has to be experienced enough, that after doing the evaluation, what kind of maintenance technique he is choosing. Okay, and then finally, this is always a bigger challenge in our country, the policy initiatives for all these research and the other thing. Okay, so with this very brief and very fast presentation, I would like to come to an end. Okay, 4 minutes before, to have some time for the interaction, because that is, I believe, always is a better one. So thank you. This was my last slide. Thank you.
So we cannot hear.
I'll be happy to take questions if there are a few. Even anyone can ask questions. Okay, let the organizer set up their things. Okay.
Hello.
Sir.
So first of all, I thank Dr. Ankit for this nice presentation. So for the audience, what I want to tell is the topic what has been given to sir is not an easy one. It requires at least 2 semester classes. So you know the depth of that subject. So he has covered entire thing without, he has covered the entire thing within 1 hour, all these 2 semester class. So now I just want to ask the audience to ask some questions, or they can put it in the chat box. I think one question is asked by Shazia Mariam. The question is, so how often we used to do the pavement maintenance?
Sir, that was question to me.
Yes.
Yeah. So can you just repeat the question? There was a breaking in the voice.
So the question is, how often do you do the pavement maintenance?
Pavement maintenance or the pavement evaluation?
Pavement evaluation and maintenance.
So obviously maintenance is based on the evaluation. Evaluation, nowadays highways are having a contract to do the evaluation twice in a year. So post 6 months, they have to do the evaluation. Normally the time period should be the pre-monsoon and the post-monsoon period. Okay, this is normally there for the highway contracts. Again, for the state highways, for the MDR, ODR, it is totally on the agencies, like how keen they are to come to the evaluation. I have seen with my little experience that such agencies are coming for the evaluation only when the structure has almost failed. They want to have an overlay, so they want to find out the thickness of the overlay. For that, they are only coming for the evaluation. But specific contracts that they have to maintain the highway for the 5 years, and every 6 months they have to do the evaluation. And the good thing is they are even fixing the equipments also. So they have to do the evaluation with the full automated equipment, which is having the laser beam, laser profilometers, with the camera mounted, everything. So all the automated equipments are there. They have to do the evaluation with that only.
Second question is, now you are having different payment deterioration models. For Indian condition, you have, do you have any specific deterioration models?
Yeah, good question, but a very difficult one, because when I say Indian condition, it varies a lot. Okay, so no pavement deterioration model could be a good one for an Indian condition. Okay, it has to be localized. Okay, then only it will be there. Okay, and the problem is with the deterioration models is, if you want to achieve the accuracy, your model will become more and more complex. If you will take only few parameters into the consideration, your models will not have that accuracy. Okay, so this is always a big challenge, that what is a good deterioration model. Should we go adding to the more parameters and move to the more accuracy level, or should we choose only less parameters and maybe slightly less accurate? But obviously the second choice is more good, to have the less parameters with the less accuracy, slightly less accuracy, but with the less parameters, because in that case you have to spend lot of less time and less money on evaluation of only few parameters. Okay, but deterioration model for a country, it is difficult.
Now, other than HDM4, do you have any other software for payment evaluation?
SDM4 is not a software for the evaluation. Okay, SDM4 is an economic evaluation we are doing. Okay, so it is giving you all the evaluation data you have to put into the SDM4. It will give you the various alternatives. Okay, the maintenance alternatives, it is being given even with the economic evaluation also. So it will give you that if you will use this maintenance alternative, it will cost you this thing, the life will be this thing. Then again, it will give you second alternative. The cost will be this thing. The life extended will be this thing. Okay. So it will give you so many maintenance alternatives. Again, it is to the engineer who has to adopt this value, who has to adopt the correct maintenance alternative, depending upon his economic conditions, like how much amount he want to invest in that particular project. But there are various other models, which is also similar kind of the programs are also coming into the market. One or two, I just had a few interaction with those company people. I'm totally forgetting. It's an Australian company which was there. I'm just forgetting its name. So there are few companies who are coming, but the good thing about the SDM4 is that their database is quite big. So kind of the models they are using or the kind of the maintenance alternatives is still being considered as a more reliable as compared to the other models. But all are these commercial software, so you can use anything.
I think one more question is there by Mr. Neeraj Singh. But what I feel is it is related to traffic. But anyway, I'll read out that question. What should be the factors to be considered for determining level of service for Indian roads?
Level of service is a big question. Again, level of service can be evaluated in the various terms, like, because you have, when I say Indian roads, it consists of expressways, highways, MDRs, ODRs. Okay, so when you say level of services, probably you have seen the speed is one of the factors by which you can have the level of services. You can have the capacities by which you can determine the LOS. Probably you must have gone through with the Indo-SCM. Okay, so there are so many factors. Again, the LOS means there's a one comment like LOSB is being followed. It's not perfect like LOSB is always followed. Depends upon your road. If your road is not very good in the hierarchy, maybe some lower roads are there, low volume roads are there. You can go with the LOSC also. Okay, so it's nothing like LOS B, C. It is totally up to the project engineers or the project directors. They can go. Yeah, LOS B is normally more considered, but it is an approximation that you can go with the LOS B or C also. But there are various factors. Okay, depending upon, still, if you are talking about the evaluation perspective, I believe you can explore this area in terms of the level of services, that how you can rate down the level of services A to F in terms of the distress conditions. So this could be a very good area, and at least a one study if someone is doing in that area, to find out the LOS on the basis of the functional evaluation.
I think with this we will end the session. Okay. So I think one more question is there. So you can answer that. I'll read out.
Sir, I'll read.
Okay, please.
Can we use remote sensing techniques to evaluate the road conditions from potholes to the thickness of the layers? So yeah, remote sensing is nothing. Still, we are exploring the things with the unmanned aerial vehicles. For me, it is difficult to say, but I'll not say it's a no. Probably, yeah, future is there for finding out this thing. Okay, so it is there in the future. I must say that the answer will be definitely yes right now. Okay, only thing we have to explore. We have now started exploring the things, and even the resolutions which we are getting from the remote sensing satellite is increasing day by day. So it's not a big deal that we can even evaluate the potholes and the thickness. The thickness is something, the GPR kind of the waves are there. You need to see that what kind of the waves should come from those satellites to the pavement layers. So it is something I'm skeptical about the thickness of the layers, but for those distresses, I'm quite positive that soon we will be having a time when by the remote sensing also we can do these things. Not a big deal.
Okay. What I feel is, with this we will end the third session. So on behalf of department and college, I thank Dr. Ankit from IIT Roorkee to spend his valuable time and giving a good presentation on pavement evaluation. So once again, thank you from my side and from my department side. Thank you.
Thank you, Vivek sir. Thank you, Institute. Thank you, everyone, for your patient learning. I know it was a very fast presentation. Okay, I apologize for this thing. I will send a copy of this presentation to Vivek sir. So those who are interested, okay, my email is there in the presentation. So feel free to write to me. Okay, sometimes I may be answering. Sometimes I'll be answering, but I'll be answering like, no, I don't know the things, because I'm not an expert in each and every field. But yeah, I will be happy to face your questions. Okay, thank you, everyone. Best wishes for all your future endeavors, and thank you, Vivek sir.
Okay, thank you. Now,
thank you, sir.
Okay.
Yeah. Should I log out, sir?
Yes, you can log out.
Thank you. Thank you.
Now, for participants, hello, can you hear me? Now, for participants, what I will do is I'll just conclude today's sessions. So today we have got 3 sessions, mainly on pavement engineering. The first session was done by Dr. Satish Chandra, former director of CRRI and current professor of IIT Roorkee. Sir explains mainly with respect to 4 pillars of sustainability. That is, with respect to environmental, economic, social, and cultural influence on that. And different types of sustainable materials like copper slag, steel slag, which are used in the field, is also explained in details. The second talk was also very useful. It was explained by one of the eminent expert in concrete technology in our country, Dr. MC Nadraj. So his talk was on high strength concrete in rigid pavement. Sir has explained characterization of aggregates and cementitious materials from point of durability and performance specification. Sir also talked on importance of mineral and chemical admixtures for durability and high performance concrete. The third talk was made by Dr. Ankit Gupta from IIT BHU on the topic of advance in payment evaluation. He talked on different types of evaluation. He explained in detail functional and structural evaluation of payments and also futuristic technologies also. Now with this, what we will do is we will conclude the session. I think today's all sessions was very informative and knowledgeable to you. Now I want to make a small announcement that tomorrow's presentation has been preponed to 9:30 since the resource person has got some meeting at 11 o'clock. So I request all the participants to log in around 9:15 sharp tomorrow 8th. Thank you.